group 2 elements which are called alkaline earth elements. The alkaline earth elements includes beryllium, magnesium, calcium, strontium and barium. All of these are typical metals, all of these, and we are also having a radium in this system, in this group, but we actually doesn't study this much, the reason being because of its radioactive nature. So we are left out with only these 5 major elements which are called alkaline earth metals. I've explained it to you why they are called, because they are the main, their compounds are the main important constituents of the plant's ash, and they all are ash, and their compounds are also found in the earth's crust. That's why they are called alkaline earth metals. Now let us move further. Let us now understand their properties. Like, let us see first their electronic configuration. Now their general electronic configuration is Ns2. Since they all are having what, 2 electrons in the valence shell, Ns suborbit, and that is why they have been placed in group number 2. So that is why what we say they are having a general configuration of 2s2. So beryllium will be having 2s2, 3 Ns2. So beryllium will be having 2s2, magnesium will be having 3s2, 4s2, 5s2, 6s2 and 7s2. This is how they go. Now let us discuss their atomic and ionic size. See, their atomic and ionic size is, when it is compared with group 1, smaller than group 1 elements. That's most important. It's smaller than group 1 elements, but remember, yes, it increases down the group. Size, as usual, it increases down the group. Why the size is smaller? Because the nuclear charge is stronger, so that the electrons are pulled with much greater force. That's why their sizes are smaller. Now let us talk about their ionization enthalpy. See, ionization enthalpy is what we can write is higher than group 1 elements. It means it's higher than alkali metals because their sizes are smaller, as well as what we find is that nuclear pull is higher, so ionization enthalpy is smaller, and it decreases down the group. It decreases because as the size increases, we know the ionization enthalpy decreases.